All right, so today I want to do a little brief lecture on partial fraction decomposition. I'm going to do a couple problems and a couple setups and just do a brief lecture on how it's set up and what exactly it is. So let's write this down. We got partial. Oh, am I in the camera? Yeah, I am. Okay, partial fraction decomposition. Okay, and let's talk about some of the key things when we're going to have to use partial fractional decomposition. There's two key situations where you're going to use this, or you have to have this situation in order to use it. If not, you need to use another method. And one, we need to have a proper rational expression. Okay, so let's discuss what this means. Proper rational expression. Well, expression, of course, we know is algebra, right? Variables, numbers. So it's an expression with variables, numbers, and operations. Rational means that it's a polynomial divided by a polynomial. Okay, so we have a polynomial divided by a polynomial. And what does it mean if it's proper? If it's proper, it means that the degree of the numerator is less than the degree of the denominator. If they're the same, then you can divide. If they're the same or greater, then you can divide using synthetic division or some other type of division, and then do this with the remainder. But in most cases, you want a proper rational expression. And what's the other case? Well, the other case is the numerator. Oh, not the numerator. I'm sorry. The denominator, the bottom fraction, the denominator, cannot be prime. You have to be able to factor it in order to break it up into different into a sum of two other things. It has to be able to be factored. The denominator does. So, without further ado, let's look at some examples that we have here. And the first one we're going to look at is 2x minus 1 divided by x plus 1, x plus 2. Okay, 2x minus 1. And what we want to do is break this up into two fractions, a sum of two fractions where the numerator is a constant number divided by x plus 1, and the second one is another fraction with a denominator of x plus 2. As these get higher in degree, if these were quadratic in the denominator, you'd need a linear expression, ax plus b. But since these are degree 1, the degree of the numerator in both of these is 1 less. Okay, so if you had a cubic down here, if you factored this and some mess got into a cubic, bless your heart if you do, then this would be a quadratic up here. Okay, so now what do we do? Okay, so now we can combine these two by adding them. Okay, so if we multiply both sides of this equation by the least common denominator, which is already given to us right here, x plus 1, x plus 2, then if I multiply this first term by x plus 1 times x plus 2, the x plus 1s will cancel. they will factor out, and we'll have a times x plus 2. Similarly, with this one, if we multiply this by x plus 1 times x plus 2, the x plus 2's will cancel, and we'll have b times x plus 1. And if we multiply this side, then everything cancels because they're already together. So now we have this expression here. And there's two ways to go from this expression. This is a big key expression. I don't know. I don't think there's a name for it. Equation. It's not an expression. It's an equation. Okay, so what do we do now? Well, now we're going to be looking for a's and b's to match these coefficients. So how do we do that? Okay, so I'm going to distribute the a and the b across this two quantities. So we'll have ax, a times x is ax, plus 2a, plus b times x is bx, plus b. And that's going to equal 2x minus 1. Okay, so now we can combine like terms. And this part is the part that people really struggle visualizing. If you take 3x plus 4x, okay, those are like terms, then you get 3 plus 4x, which is 7x. And everybody sees that pretty easily. But a lot of people struggle with this whole concept here. If I take ax plus bx, I'm given a plus bx. A lot of people have problems visualizing that in my experience as a tutor and teacher. And then what's left is plus 2a plus b. So this is like, if this expression here is in front of the constant. So that means for these to match, we have a system of equations. A plus b is equal to 2. And 2a plus b is equal to negative 1. Easy enough. There's two ways you can solve this: by elimination, or you can solve it by substitution. Let's use elimination. Let's take the bottom equation and subtract it from the top equation. Okay, so b minus b is 0, so that'll eliminate the b's. A minus 2a is negative a. And 2 minus negative 1 is positive 3. So a is negative 3. Then we can go back into the top equation. Negative 3 plus b has to equal 2, and b doesn't equal 5. So I screwed up somewhere. I always do this. Man, I've done this problem 12 times today, and let's see where I screwed up. I made a mistake somewhere. Okay, we have 2a minus b equals minus 1. A minus 2a is minus a. 2 minus 1 is negative 3. A is negative 3. Okay, that's right. Negative 3 plus b is 2. B is not 5, though. Pretty sure b is not 5. So if we solve for this here, b would be 5. Maybe it is 5. Let's see. I don't think it is. Okay, let's check. We can check if it's 5. So it's 3 over x plus 1 plus 5 over x plus 2. And we add that up, then we get negative 3 times x plus 2 plus 5 times x plus 1. And that's going to be negative 3x minus 6 plus 5x plus 5. And sure enough, it is 2x minus 1. It is 5. Okay. Well, always check yourself. Okay, so that's how you check it. So a is negative 3, and b is 5. Sorry, I butchered that. Let me make sure I check this right. Negative 6, yep. Nope, that would be, yeah, that's minus 1. Negative 6 plus 5, yeah. 5 minus 3 is 2x. Yep, that's right. Okay, so 2x minus 1 divided by x plus 1, x plus 2 is equal to negative 3 over x plus 1 plus 5 over x plus 2. All right, that is the first problem. Now, let's redo the first problem, except we're going to use what's called the Heaviside Method, because it's a shortcut instead of writing all these equations. And you still have to do everything up to this step right here. So we're going to use our big equation here. 2x minus 1 is equal to a times x plus 2 plus b times x plus 1. So we're going to use this equation right here. This is called the Heaviside Method. It's named after a guy named Heaviside. Okay, so this bends the rules, because what I'm going to do is eliminate one of these terms. And technically you can't do that, because to eliminate this term I would let x equal negative 2. Okay, you can do it in this equation. You can't do it in this equation. That's why it's bending the rules. Why can't you do it in this equation? Because you can't divide by 0. But it's perfectly okay in this equation. And it works, so don't complain. It's a trick. Okay, so if x equals negative 2, x equals negative 2, then this term goes away. This term goes away if x is negative 2. If x is negative 2 here, we have negative 2 plus 1. That's negative b, right? Negative 2 plus 1 is negative 1. So negative b is equal to, now over here, negative 2 times 2 is negative 4, minus 1 is negative 5. So b is equal to 5. And now I see why I've got a strange answer, because my example was 2x plus 1, not 2x minus 1. But okay. Never doubt yourself. So b is equal to 5, which we found over here. Now let's do the same thing if x is negative 1. Right? This goes away. 2 minus 1 is a, right? 2 minus 1 is 1a, is equal to, here, x is negative 1. That's negative 2 minus 1 is negative 3. So a is negative 3. And that's the Heaviside Method. The Heaviside Method does not work for all of these. It does not work for quadratic equations. Good luck using, like if these are quadratic in the bottom, good luck. It doesn't work. It doesn't work if you have repeated things like exponents. It doesn't work. You have to use the long method. But actually, when you have the repeated deal, which was one we're going to look at next, it's actually a little easier. You're going to see why here. Okay. Let's try another simple one, though, first. Let me see if I can find a good example. And I had them up, and I don't know where I put them. It's terrible, huh? Let's try a simpler example first. Yeah, it was 2x plus 1, and I did 2x minus 1. Let's do this one. Let's do a little more complex. Let's do 3x minus 5 divided by x minus 1, x minus 2, x plus 2. And I hope you realize that the hardest part of this is factoring the denominator. That's the hardest part. Okay. So, when we factor this out, we get a over x minus 1. And it doesn't matter what order you put these in, but I'd like to go from left to right just to be b over x minus 2 plus c over x plus 2. Okay, this part is not hard, it's tedious. Okay, so to get to that first equation, this guy gets the other two. Just remember that, because when you multiply across, this guy's going to cancel. This guy's going to cancel when you multiply the middle one. This guy's going to cancel. So it's going to be a and these other two, x minus 2, x plus 2, plus b times x minus 1, x plus 2, plus c times x minus 1, x minus 2. Okay. Now for the hard part, foiling. Okay. But for the Heaviside method, you can use this equation. Okay, I want to do it the long way first. I don't know. I guess I have a point to prove. I want to kill some. X minus 2 times x plus 2 is x squared minus 4. Plus b times x squared. 2 minus 1 is plus x minus 2. Plus c times x squared minus 3x plus 2. Okay. If you need help foiling, I guess we can do another video on foiling, but if you're this far and you haven't done foiling, then I don't know how to help. But okay. A distributed over there looks like this, and then we'll distribute the B, and then we'll distribute the C. Okay. We got ax squared, and when I'm done with these, I like to underline them. Ax squared, so there's a, plus bx squared, plus cx squared. And I just said I'd like to underline them when I get them in there, and I didn't do it. That's x squared. Plus bx, so there's a b minus 3c. Remember this term, this makes it a little easy that this term doesn't have a, and you'll see why in a minute. Okay. So it's b minus 3cx, and then, there's a x and an x. And then 4 plus negative 4a minus 2b plus 2c. Okay. So, here we go. Here's our equations. A plus b plus c is equal to what? What's the coefficient of x squared? There isn't an x squared. It's 0. All right, now we have a coefficient. B minus 3c is equal to 3. And negative 4a minus 2b plus 2c is equal to negative 5. Now there's a lot of different ways to do a 3 by 3. You could do a matrix. You could do a lot of different things. But the best thing that I see here is just, this is a nice little, that b is equal to 3 plus 3c. Okay. So we can take this equation out of the equation. And I'll show you how. Okay, so let's look at so we're going to use the first and the bottom equation to eliminate a variable. And we're probably going to eliminate a because we have a formula for b with c in it. Okay. And the emergency weather broadcasting service is letting us know something's happening here. Okay, so let's plug this. So wherever we see a b, we're going to have a plus 3c, that's b, plus c is equal to 0. And in this one, we're going to have minus 4a minus 2b. Okay, so minus 2b would be minus 6. Okay, minus 6 minus 6c plus 2c is equal to 0. Okay. Now, let's sort this out a little bit so it's a little prettier. We're going to have a. If I subtract 3 from both sides, so it's a plus 4c. I'm going to go ahead and combine those and subtract 3, like that. Okay, so I subtracted the 3 to this side, and I combined those two. All right, now, negative 4a, I add 6 to both sides, and then we'll have minus 6. Oh, look, it's so much easier to eliminate c, too. That's a bummer. Well, that's okay. We'll do that anyway. Minus 4c, because minus 6 plus 2. Okay, so let's eliminate the c's just because it's a lot easier. And look, it's a multiple of 3 too, so that's really good too. This is minus 3a is equal to 3. If we add those up, yeah. So a is minus 1. A is equal to -1, and -1 plus 4c is equal to -3, right? So we add 1 to both sides, so c is 1/2. Oh, that's ugly. I don't like them when they're ugly. Yeah. So 4c is equal to -2, and c is -1/2. And then b is equal to 3 plus 3 minus 3/2, which is 3/2. Okay. So we get, now we have to check it. Okay. So I want to rewrite this up here as our answer. So we said that 3x minus 5 is equal to a over x minus 1 plus b over x minus 2 plus, all over x minus 1, x minus 2, x plus 2. All right. Plus c over x plus 2. Okay. So let's fill in the blanks here. And that's tacky looking, I'm sorry, but not really. So 3x minus 5 over x minus 1, x minus 2, x plus 2. And there's a train coming, so bear with the train. I just have all kinds of noise going on today, don't I? Is equal to -1 over x minus 1 plus, and you can write this like this because b was 3/2. 3 over 2x minus 2. Okay, that's how we're going to write it for right now. When you're integrating or using other stuff, you're not going to write it like that. And you're going to see, I'm just checking my work. You're going to see it's easier to write it like this. Plus, let's see, the last one is minus 1 over 2 times x plus 2. Okay, so we have to combine all the like terms here. And the best thing to do is to make this, put a 2 there. And then we have all like terms on the bottom. We don't have to worry about the 2's anymore. So now we're going to have -2 times these two, which is x squared minus 4. I'll go ahead and jump ahead because we already got these foiled out. Right? If I multiply x squared times x squared plus x minus 2x squared plus 2, we get this. Plus 3 times these two, which is x squared. I'm kind of jumping the gun here, but I'm just checking my work. You don't have to do this. 2x minus plus x. Yeah, plus x minus 2. And then minus these two multiplied together, which is x squared minus 3x plus 2. This should equal 3x minus 5. Let's see if it does. Okay, minus 2x squared plus 8 plus 3x squared plus 3x minus 6 minus x squared minus plus 3x minus 2. Okay, so x minus and minus, that's all 0. That's good. That's what we want. So those all go to 0. 8. Uh-oh. Here's where the screw up right there. 8 minus 8 is 0. Now we don't want that to be 0. So that's not right. Something's screwed up. Definitely. Eight minus 6 minus 2 is 0. We don't want that to be 0. We want it to be minus 5. So we screwed up somewhere. Great. Love doing videos and you realize you made a mistake. Okay. Let's try again. You get the point. Alright. Let's try again, but let's use Heaviside, okay? And then we'll see where we made our mistake. We're going to use Heaviside because it's a lot easier. So this is equal to a times x plus 2 times x minus 2 plus b. I know this part's right. And I probably screwed up somewhere. And if somebody wants to comment where I screwed up and notice where I made a mistake, please go for it. Okay, Heaviside. Heaviside makes this a whole lot easier. Okay, so we have, let's find our 3 different zeros. That's first. And when it's 2, it's real simple to see where the zeros are, but when there's 3, it's not so easy. We have -2, +2, and +1. -2, +2, and +1 are the 3 zeros. Okay, so if I plug in -2, right, this is 0 and this is 0. So we're going to have C times -2 minus 1 is -3, and -2 minus 2 is -4. So this is 12C is equal to -2 times 3 is, wow, that's nasty. Why would you give somebody such a nasty problem? I guess they just made these up. All right. That's -11, yeah? -6 minus 5 is -11, so C is -11 over 12. Okay, let's do the same thing with B. In this case, we need x equals 2, +2. X equals +2. If x is +2, these two go away, so then we're going to have 2 minus 1, which is 1. And then 2 plus 2 is 4. So 4b is equal to 3 minus 5. No, 6 minus 5 is 1. So b is 1/4. And then on this one, x is 1. So 1 minus 5, 3 minus 5 is -2, is equal to a times 3 times -1. Which is a is equal to -2/3, +2/3. Yuck. Yuck. Did I write that? I hope I wrote that problem down wrong, because it is gross. That is just disgusting. (3x minus 5 over x minus 1, x minus 2, x plus 2). Okay, let's check this. And let me see if I can find a way to... Oh, yeah, I can. Okay. To show you how I'm going to check it. So we're going to use what's called Wolfram Alpha. And it's pretty sad that Wolfram Alpha really makes this look disgusting. Okay. Partial fraction. And so right here, we're going to put our rational function. And our rational function here is 3x minus 5 divided by x minus 1, x minus 2, x plus 2. Watch how fast this is. This is going to make you sick. Okay, here goes. Invalid value. What? Did I close my parentheses? No, that's what I did. Okay, close your parentheses. Make sure you have a valid little deal there. Okay. Yeah, that's exactly what it is. Okay, so it was A was, if you look, let me go back. A was 2/3. B is 1/4. Oh, actually, yeah, B is 1/4, and C is -11/12. So whoever did that was not very nice to their students, I guess, because that's ugly. But then again, real life isn't always pretty. Okay, let's try one more of a different type. Especially do one that I just did the answer to. So I know that I get the answer right. Okay, here we go. This last one is different. It's going to be 2x minus 1, but in the denominator, we're going to have x minus 1 cubed. And I know these look scary because they can get really gross with their sometimes, but you can't use the Heaviside method on this because you have repeated roots. If you let 1 equals, if you let x equal 1, they all go to, they all go to 0, so you can't do that. So this is going to equal a over. Now, when you have powers like this, you have to have one for x minus 1. And then you have to have one for x minus 1 squared. And then you have to have one for x minus 1 cubed. Okay? Not too bad. All right, so everything we're going to multiply through here is going to cancel with this. So 2x minus 1 is going to equal a times x minus 1 squared. All right, because x minus 1 cubed divided by x minus 1 is x minus 1 squared. Plus b times x minus 1. All right, x minus 1 cubed divided by x minus 1 squared is going to get b times x minus 1. And then plus c, because those are going to cancel there. All right, so what do we have here? What is x minus 1 squared? X minus 1 quantity squared. Which is going to be a times x squared minus 2x plus 1 plus b times x minus 1 plus c. This looks hard, but you're going to see how easy this is. You're going to be like, oh my gosh, that one's the easiest one. Okay, so this is ax squared minus 2ax plus a plus bx minus b plus c, okay, is equal to 2x minus 1. All right, let's combine like terms. Oh, look, there's only ax squared, right? There's no other x squared, so ax squared. And you'll also see why that's nice, because there's no x squared term, so we know what a is already. A is 0. Okay, let's see, what else we got here? We got a bx and a 2ax, so plus negative 2ax plus b, oh, there's no x there, plus bx. So 2a plus bx plus a minus b plus c. A minus b plus c. Okay, we already know right off the bat a is equal to 0. This term is not in the answer. A is equal to 0. So this means that b plus 2 times 0, so bx is equal to 2x. That means b is equal to 2. How easy can this be? Huh? Negative 2 plus c is equal to what? Negative 1, right? A minus b, b is 2, so a is 0, so minus 2 plus c is equal to, this term is equal to minus 1, so c is equal to 1. Okay, so this means that 2x minus 1 over x minus 1 cubed is equal to, b is 2, 2 over x minus 1 squared plus 1 over x minus 1 cubed. Now I can do it on, this one is so easy to check, okay? It's pretty easy to check, because if you multiply this by x minus 1 and x minus 1 here, right, you get 2x minus 2 plus 1, that's going to be 2x minus 1, which is that. So that's an easy check. Easy check. That's an easy one. Let's see if there's another one like that. And I'll finish off with 4 problems on the night. If you need further help with partial fractions, check me out on Facebook, facebook.com/Mathspace tutoring. I'll put a link below. I can slow down, do it live. I'm reasonably priced, $15 to $20 an hour. You don't have to leave your house. Of course, YouTube videos are free, and you can watch them over and over and over and press pause and slow down my voice and do all kinds of neat things. Let's do this one. 3x plus 2, and I haven't done this one yet, so divided by x minus 2 cubed. Let's do another cube one. And these look scary, but these are actually the easier ones. Okay, so remember that this is going to be a over x minus 2 plus b over x minus 2 squared plus c over x minus 2 cubed. Now, somebody asked me, is it okay if you put the cube first and then do yes, it doesn't matter, okay, because they're all gonna match in the end. Okay, so let's do this. If we multiply the first term, a is going to have a is going to be multiplied by x minus 2 squared plus b times, if I multiply this by this, we'll have x minus 2 plus c times nothing. C, because cubes are going to cancel there. All right, this is going to equal 3x plus 2. Okay, let's multiply this out. This is x squared minus 4x plus 4 plus bx minus 2b plus c. Okay. So, because all this has is a tacked on it, I'm going to kind of jump the gun here. Okay, this is equal to 3x plus 2. Okay, ax squared. Guess what a is going to be? Minus 4a plus bx, so it's minus 4. It doesn't really matter, does it? Because what's a? 0. Plus bx, plus b times x, okay? And then plus 4a minus 2b plus c, okay? And let's go ahead and box these coefficients. All right, so b is 3, okay, because a is 0, and bx equals 3x, so b is equal to 3. So negative 2 times 3 plus c is equal to 2. So c is equal to 8. So, is that correct? Does that mean that 3x plus 2 over x minus 2 cubed is equal to b is 3 over x minus 2 squared plus c, 8 over x minus 2 cubed. Okay, is this true? Let's see. We're going to go into... oh, I don't want to go to there. I want to go here. All right. Let's see if this is true. So we're going to type in this expression. So it was 3x plus 2 divided by x minus 2 cubed. All right, play the Jeopardy song. Let's see if we get it right. Three over x squared, x minus 2 squared plus 8 over x minus 2 cubed. That's exactly what we got. I appreciate you watching. If you like this video, please drop me that thumbs up. If you need further help, check us out on Facebook. My Facebook tutoring slash... Wait, Facebook.com/Mathspace tutoring. Facebook.com/Mathspace tutoring. And we'll see you soon. Thanks for watching.